can do example 1.6 from the chapter Electric Charges and Fields. We can read the question. Consider charges Q, Q and minus Q placed at the vertices of an equilateral triangle. What is the net force that is acting on each charge? So you can see at the three corners of this equilateral triangle, three charges are there. These two are positive charges Q and Q. And in the third corner, you can see a negative charge minus Q. The question is, you have to find out the force, that is net force, that is acting on each of the corners. So first we can start with the first corner, having Q1, charge Q1, that is equal to Q. So you can see that this charge Q1 will get force from the two other charges. This Q3 will give a force to this charge and this Q2 will also give a force to this Q1. Okay. And you can see that since charge Q is a positive charge, like charges repel each other. So the force between Q1 and Q2 is a repulsive force. The force that Q2 gives to Q1 will be directed away from Q2 because it is a repulsive force. Okay. And again, this Q3 is also giving a charge force to Q1. But you can see that this Q3 is a negative charge. So Q1 is positive. Then the force of there is a force of attraction between them since they are having opposite charges. So the direction of the force will be, it will be the force that this Q3 give to Q1, its direction will be towards Q3 since it is attractive. Okay. So the two forces F12 is a force given by 2 to 1 and F13 is the force given by 3 to 1. It is marked here. Okay. Now we have to find out the resultant force, the total force. Okay. Total force at the charge Q1. Okay. How can you find out the total force? One force in this direction, F12 is in this direction, F13 is in this direction, then the resultant force will be along this direction. So we have to find out the resultant force using parallelogram law of vector addition. Okay. So what is the equation for finding the resultant force using parallelogram law of vector addition? F is equal to root of F1 square plus F2 square plus 2F1 F2 cos theta. Right, this is the equation. So here first we have to find out the magnitude of these forces. What's the equation for finding the force? 1 by 4 pi epsilon 0 Q1 Q2 by R square, right? So when we consider this F12, the force given by 2 to 1, the equation will be 1 by 4 pi epsilon 0. Both are Q, right? So Q1 and Q2 both are Q. So you can write Q into Q divided by L square. L is the distance between them. Okay, L square. So on rearranging, you can write it as Q square by 4 pi epsilon 0 L square. This is the force. When we consider the force given by this 3 to 1, it is also having the same magnitude because the charges are same Q and Q. Sign is there, but the magnitude, when we consider the magnitude, the charges are same and the distance is also same. So its magnitude will also be same. Q square by 4 pi epsilon 0 L square. Then we have to find out if we want to use the parallelogram of law of vector addition, we need to find out the angle between them, right? This is 60 degree because this is an equilateral triangle. So this angle will be how much? 120 degree, right? So substitute the value for finding the net force. You have to do F square. Both are having the same magnitude. So we can take it as F. So F square plus 2 into F into F. That is 2 into F square cos 120. What is the value of cos 120? Minus half. So it will become 2F square plus 2F square times minus 1 by 2. This 2 and this 2 can be cancelled. So this will become 2F square minus F square. 2F square minus F square is F square. Root F square. Root F square will be what? F. And what is the direction of this F? You can see this is in this direction. Parallel to this one, you can see another line here. That means that's the direction of BC. So for that direction, we are representing that direction by R1 cap. Okay. So we can write the net force as F R1 cap, where R1 cap is a unit vector along BC. Okay. Is it clear till there? So we found out the resultant force on the first charge Q1. Okay. And what is the value of it? F and the direction R1 cap, where R1 cap is a unit vector along BC. Now we are going to find out the resultant force in this one. It's same as the first thing. This Q2 will get a force from Q1. Both are positive, so it is repulsive, directed away from first charge. And this one second one will also get a force from the third one. Since that is a negative charge, unlike charges, so there is attraction. So the force will be attracted toward, direction will be towards Q3. Again, we have to find out the resultant force. The same step from the parallelogram law, we will get the same answer. That is F2. The resultant force F2 will also be equal to F. But we have direction. Look at the direction. This is the direction of F2, right? Parallel to that, you can see another one, this. So it is the for giving the direction, we use an unit vector R2 cap. And what is R2 cap? R2 cap is a unit vector along AC. Unit vector along AC. Okay. Now we have one more charge here located at here, that is Q3. We have to find out the resultant force that Q3 gets. Okay, for Q3, Q1 will give a force to Q3 and Q2 will also give a force to Q3, right? Since Q3 is negative, the force is attractive, right? So this Q1 will try to attract Q3. So direction will be in this direction, and also here also the force will be towards Q2. So this is in this direction. Okay, so the resultant will be in this direction. We have to find out the value of the resultant. For that, again we have to use the parallelogram law of vector addition. Root of f square plus 2f square. And what is the angle here? Angle is the inside angle, right? It's for equilateral triangle, so the inside angle is 60. So cos 60. And what is cos 60? Cos 60 will be 1 by 2. Okay, substitute the value of 1 by 2. 2 and 2 get cancelled. So we will get the answer as root 3 f square. Okay, root 3 f square. Cos 60 is 1 by 2. So give that value of 1 by 2. So you will get root 3 f square. Root 3 f square. When you take this f square out of the square root, it will become f. So the net force will be root 3 f. And the direction is marked as n cap. And what is this n cap? N cap is the unit vector along the direction bisecting angle BCA. Okay, this is angle BCA. Bisecting the BCA, this n cap, that direction is coming. Okay. Now, these are the forces on each charge. In the first charge, the force is F into R1 cap. In the second charge, the force is F into R2 cap. And in the third charge, force is root 3 F n cap. Okay. And also, you can see this is the direction of F1, right? And this is the direction of F2. Okay. And what is the resultant of these two forces together? What is the resultant of these two forces? The resultant of these two forces is F in the upward direction. Okay. And you can see another force F in the downward direction. Okay. So the resultant of these two forces, this F and this force F, will cancel out each other. So when we find out the net force will be F1 plus F2 plus F3 will be equal to 0. Okay. So that's it, how to solve this question. Hope you all understood it. Okay, in the next video, we can do the next example. Thank you.